good day. This is Kathleen Grancapal. So today I'm going to show you my reflection video by answering a few questions regarding on lesson 1. So let's get right on the video. First of all, honestly, when I read the title of the lesson, Biochemistry, Overview and Occurrence of Carbohydrates, I was like, okay, it's all about carbohydrates, its importance, functions, terms about biochemistry, and something like this and like that. I mean, it's all about a little bit easy stuff. But as I dig deeper, as I read the whole learning material, I realized I was wrong. Like, what I was expecting didn't happen that way. I expect that it is easy, but it turns nothing. Literally, it's not easy. That's why, from now on, I won't expect too much because it's always better to feel surprised than to feel disappointed. The lesson was indeed challenging. Learning depends on the application of previously learned concepts from chemistry and biology to new biological contexts. It takes time to get the point and let it sink into your mind. Studying this is engrossing, not tough, because there are some topics that are indeed confusing. I'm afraid by myself to not get the point of the lesson. On the other hand, the lesson was interesting and effective since you will learn a lot regarding the topic. And of course, before I forgot, I really love and appreciate the teaching strategy that my instructor did, because for me, this subject was quite boring and it requires a lot of concentration. And here she is, finding ways in order for her students to not get bored on the lesson. That's why I really appreciate her strategy. Thanks to that one of a kind. And frankly speaking, sometimes I can't focus on what I am reading because I'm distracted seeing those anime characters that are very cute. But I'm not mad at all. I was glad to see those strategies, and yeah, it was effective because you'll not get bored while studying the topics. The topics I've encountered in lesson 1 that I find difficult to understand are the Fisher and Howard projection formula, stereoisomerism, enantiomers, diastereomers, and chirality molecules, because there is a need to understand those formulas and how they are connected. It requires more dedication and more will to study and to understand the details of all the chemical processes and reactions occurring inside our body. The subject is itself very vast and it requires excess efforts to get a grip on it. I feel confused about some illustrations and sometimes I can understand it very well. The topics I've encountered in lesson 1 that I find easy to understand are the functions and importance of carbohydrates, classification of carbohydrates, and biochemically important monosaccharides, because there are some points and terms that are easy to get and not hard to understand. The math requirement is far less and it's more dependent on memorization. It's much easier to conceptualize, and the aspects of the discipline all help to make it easier to grasp and understand. We need to learn about left and right-handed chirality molecules because it plays an important role in the recognition phenomenon between biologically active molecule and its target. Also, we need to understand that chiral molecules have the same things attached in the same order, but are mirror images and not the same. Just like our right hand, it mirrors our left but will never fit comfortably into the left-handed glove. The left hand is a mirror image of the right one and they cannot be superimposed no matter how the two hands are oriented. Amino acids and sugars is a twin, not an identical one but a mirror image. They come in both right and left versions. Moreover, chirality is a particularly important concept because cells are mostly composed of chiral molecules. Small chiral molecules such as amino acids and sugars are the building blocks of larger molecules such as proteins and nucleic acids, which are also chiral. Chirality is a fundamental property of molecular systems and underlines many fundamental biomolecular processes. We need to learn chirality because it is an important method for the investigation of protein structure and structural changes during interactions. Lastly, it allows powerful insight to be provided, explain experimental data, validate predicted structures, and explain fine details of biomolecular interactions. That's why we need to understand the concept of chirality and handedness because it has a big role that applies to the structure of molecules, which is very relevant in our topic and subject as well.